Alright, so in this video we're going to be solving exponential equations that involve the number e. Alright, so our first one that we're going to look at is something that looks like this. 3 times e to the 0.5t equals to 11. Okay. So what I want to do here is I want to isolate the exponential here. This is in this case our e exponential with base e. So I'm going to divide both sides here by 3. So this reduces to 1. So we have on the left side we got e to the 0.5t, and on this side we have 11 over 3. Alright, now for something like this we have e to the 0.5t. So instead of taking the common logarithm, I'm going to take the natural logarithm on both sides. Right, so the ln of both sides, and then here using the power rule, this 0.5t becomes the coefficient of the natural log, and here we have ln of 11 over 3. Okay, so here, right, looking at this, right, I'll use the property of logarithms where, again, this is a log base e, same base as the argument, so this value is simply just 1, right? So 1 times this leaves me with 0.5t equals to ln of 11 over 3. And then here, the next step would be, right, we're almost there, right? We have the t by itself. We get 0 to the 0.5, or divide by 0.5 on both sides, and we get t equals to the ln of 11 over 3 over 0.5, right? And let's say that we did want an approximation for this value. Right, so I'll take out my calculator and I'll plug in on the natural logarithm of 11 over 3 and divided by 0.5, and we get, if we go to 2 decimal places, we get approximately 2.60, right, rounded properly. Okay, so that's how we would use the solving equations with involving e. We'll take the natural logarithm and then just take advantage of this property that natural log of e is equal to 1. And we can do that with any base really, but here in our calculator we really just have 2 logarithms that we can use, the common logarithm and the natural logarithm. So let's look at a different equation that will also have base e, and we'll take a different approach here. Now, before we get into that one, I just want to remind you about the quadratic form of an equation. When we studied the quadratic equation, we had this quadratic form that we were able to use. We would either try to factor it, right? And if that didn't work, we would use the quadratic formula. So we can use this same kind of pattern where we have the x squared and then the linear term of x and then a constant term, right, without x, to apply those same type of techniques of factoring, or in some cases the quadratic formula, where it's not a quadratic, but it is a quadratic type, right? So what I mean by that is, let's say that we had something like this. E to the 2x equals to e to the x plus 2. All right, so I'll subtract. So what I'm going to do here is, notice I have 2 exponentials with base e, right? But they don't have the same exponent, so they're not like terms, right? I can't combine these in this form. So instead, what I'm going to do is I'm going to set this equal to 0. So I'm going to subtract e to the x, subtract 2. So now I have it equal to 0. So again, this is not a quadratic, right? So if I were to graph this, it's not a parabola, but it is what we call a quadratic type, quadratic form, where we have a squared term, a linear term, right? And I say square, even though you say it's 2x, you see that it's 2x, right? Remember that in terms of our properties of exponents, e to the 2x is equivalent to e to the x squared. Okay, so it is a square term, a linear term, and a constant term, right? Now, maybe to help us kind of visualize that more, we can say, all right, I'm going to let y equal to e to the x. Right, so I'm going to make this substitution. So if I do that, then e to the 2x becomes y squared minus y, right, because that's my substitution, and then minus 2 equals to 0. Now this is a quadratic in y, right, and now I can try to factor this, right? We can say, okay, well here we have y minus 2, this looks like this will factor, y plus 1 is equal to 0. Okay. And now we have two solutions here. Y is equal to 2 and y is equal to negative 1. But this is not the solution to my problem, right? I was asked to solve for x. Right? I solved for y, so we need to substitute back again here. Right? So here, going back to my substitution, if y is equal to e to the x, let's sub that in and find, now we'll look for the values of x. Okay? So here, 2 is equal to e to the x. And then we'll take the log, natural log of both sides. So we have natural log of 2 is equal to x. All right, because remember, natural log of e to the x, bring the x as the power, becomes a coefficient, right? Applying the power rule. Natural log of e is simply 1. So we're left with this. So now I have one of my solutions. All right, now when I go to plug in my other solution, I run into an issue here, right? Excuse me. When we introduced the exponential, we said that the range was all positive values. Well, I don't have a positive value here, right? So this is not going to be a solution. All right, so we just have what's called an extraneous solution. All right, so it's extra. It's yeah, so that's why it's important to kind of, when dealing with these exponentials, when we do these substitutions, just make sure, double check here that both of these work out. Okay, and if you didn't see that initially, when you go into and try to evaluate, let's say, natural log of negative 1, you'll get an error, right? And the problem is that, right, the problem is in this here. There's just no solution here. So we have one solution, that being the natural log of 2 is equal to x.